Okay, looking at chapter 10 here, we're going to study some analytic geometry topics. We're going to look at our conic sections here, and we'll start with the parabola. So, talking about conic sections, we'll be talking about the parabola, the circle, ellipse, and the hyperbola. And then we'll take those different equations and we'll look at solving some nonlinear systems using these conic sections and also inequalities. So first off, what is a conic section? A conic section is the intersection of a plane and a cone. By changing the angle and location of the intersection, we can produce a circle, ellipse, parabola, or hyperbola. Or in the special case, when the plane touches the vertex, a point, line, or two intersecting lines. So you can see down here, you've got your plane intersecting this cone. All right, you can see here the circle, we're intersecting this cone here at a horizontal intersection, slicing through it horizontally, and it forms a circle. And if we take that same plane and we put it at an angle where it slices through both sides of the cone, and it takes off that section, and we get an ellipse, an elliptical graph, and we'll study our ellipse and circle in our next section. And then if you look at this third picture, this third diagram, you can see this plane intersecting one side of the cone, and that intersection takes out what we call a parabola. It's a quadratic graph. And then you can see the hyperbola as you look at these two cones standing on top of each other, and you take a plane, intersect both cones, look at it here vertically, both sides are here, again, one side of each cone. You see the hyperbola forming. So we'll take a look at these conic sections. Now let's define a parabola. It says a parabola is a set of all points in a plane equal distance from a fixed line, in which we call the directrix, and a fixed point that's not on that line, which we call the focus. The line that is perpendicular to the directrix and contains the focus is the axis of symmetry, or the line of symmetry, right, which we've studied before in parabolas, right, in quadratics. We know the line of symmetry on a quadratic function graph like this one is that vertical line passing through the vertex, right? It splits it right down the middle into equal parts. Well, perpendicular to that, you see this horizontal line drawn in. That's your directrix. So we use the directrix and the focus, right, to measure distances, right, from the points that are on this parabola, make up the parabola. All right, so it has the vertex, the midpoint of the segment between the focus and the directrix. But with that said, any point on this parabola, right, as we look at, for example, here is a point on the parabola. If you measure the distance, right, to the focus, it's equal to the distance to the directrix. So if that was D1 and this is D2, D1 is equal to D2. Any point, and of course the vertex to the directrix and vertex to the focus, right, they're the same distances. If that was D3 and this was D4, D3 equals D4. So again, any point on the parabola, the distance is always equal, right? So again, you're measuring your distance from the focal point, the focus is fixed point on the line of symmetry, and again the directrix, which is the line that's perpendicular to the line of symmetry. Right, so again, that's defining a parabola, the set of all points in the plane that is the same distance from the fixed line the directrix is from the fixed point not on that line, which we call the focus. All right, let's take a look at the standard form equation. So here it says the standard equation of a parabola with a vertex at HK and a vertical axis of symmetry. So here we're looking at our quadratic function graphs, right? We're looking at this graph here that opens up, right? We have a vertex, which is the midpoint, right, of this parabola. And at that point, we're going to label the coordinates of h and k, x coordinate represented by the number h, and k representing the y coordinate. And then we have this fixed point. This is what we call the focus. And to measure that distance from the vertex to the focus, we're going to use that with the value of p. So p will be that distance traveled from the vertex to the focus. So if we went to the focus, we went out p units vertically. So we added p to the y coordinate. So you can see the focus is hk plus p. and then we would go that same distance. Remember, any point on the parabola, the same distance is to focus is to the directrix. And we go p units down to the directrix, which is this horizontal line, which is perpendicular line of symmetry. And of course, horizontal lines are y equal to a constant, so we got y equal to k minus p for the equation of the directrix. So again, that's your standard form equation over here, which in a parabola, in a quadratic, we know we have one squared term. And of course, in a quadratic function, we're looking at a y equal x squared graph, right? This is a quadratic function graph. But our standard equation, our standard graphing form, is x minus h squared equal to 4p times y minus k. All right, so we're looking at, again, the standard form here. So our squared term, we're going to isolate, and we'll create the square with it if we don't have it. And again, the squared term will form the x-coordinate of the vertex, right? X minus h squared here. X term, of course, it gives the x-coordinate. And then the y term, we're going to put on the other side of the equation, and its coefficient, which is represented by 4p, right, will allow us to get to our focus and directrix, allow us to find that value p. And the y term, we got y minus some constant k, k being the y coordinate of the vertex. So again, the x term, of course, forms the x coordinate, the y term will form the y coordinate, and p will tell us where the focus and the directrix is based off that. So we'll go up and down p units, and it depends on the value of p. If p is greater than 0, we go up to the focal point. If p is negative, we go down, right, to the focal point. So again, it depends on what type of parabola we have, depending on which way it opens. So again, greater than 0, it opens up. Less than 0, it opens down. So standard form for a quadratic function graph, x minus h squared equal 4p times y minus k. Now let's take a look at our parabolas that open to the right or left. Now these are not graphs of functions, right? These fail the vertical line test. Right? For each x, we don't have exactly one y. We see that in our graph, and I've shown it in here. As we look at this graph here, and our vertex, here is this point hk, right? This starting point of this parabola opens to the right. And we measure out a distance of p units. So here's that value of p. And of course, that's the distance traveled to the focus and to the directrix. If p is positive, we go right. P is negative, we go left. The parabola would open left, right, if we had a negative value. But again, we go same distance to the focus, we do the directrix. And you see the directrix is a vertical line here, right? This is our directrix. And of course, the line of symmetry, right, is our horizontal line this time. It's perpendicular to the directrix. So again, we're going right and left, so we're adding, right, and subtracting p from our x-coordinate of our vertex. So you can see that here with the focus at h plus pk, and of course our directrix, the vertical line x equal constant, x equal h minus p. So you see your standard form. So looking at a example, right, of a standard form equation at, of course, origin, we got x squared equal 4py. And y squared equal 4px, all right? But again, that's assuming we had 0, 0 for the vertex. All right, let's take a look at example. Let's go find the focus, the directrix of this parabola. So let's look at getting the characteristics as quadratic. Now, this is a quadratic function graph, right? A y equal x squared graph. Now, we know since we have a negative coefficient, we know graphically we're going to have a graph that takes that shape, right? Opens down. So based off that negative x squared graph. So y equal negative x squared graph opens down, x squared opens up. So let's find this information for this parabola. Now, standard form. Let's go ahead and write down what we would like our equation to look like. So standard form is we're going to isolate the x squared term, x minus h squared equal to 4p times y minus k. So in this problem, we've got y. So in our example, right, we're looking at y equal to negative 1/12 x squared. Well, my first step is I want to get it in standard form. So I want to isolate the x squared term on one side. So let's go ahead and do that. Let's put it in a different color. I'm going to go ahead and get rid of the coefficient. So let's go ahead and multiply both sides by negative 12. Right, and as we do that, right, we're going to look at our equation in the form of negative 12y equal to x squared. And then as we look at that, now we've got our standard form, right? Here's our equation in the form of x squared equal to negative 12y. And if you want to write it in standard form, that's x minus, right, 0. Right? X minus 0 is x. So you can rewrite an x minus h squared form equal to negative 12 times y, right, minus 0. So again, I'm writing it here in standard form. There's our standard form equation, right? There's x minus h squared. So we've got what we were looking for. We've got our goal, right? So our standard form, which we can write right beneath it, x minus h squared equal 4p times y minus k. So in this problem, we know that h, right, here's our value of h. There's k, and there's our value of 4p. So we've got a vertex, right, at the origin. So the vertex equals the ordered pair h and k. So in this problem, it's at the origin. What's subtracted from x is 0, and our x squared term. What's subtracted from y is 0, so our y coordinate is 0 in the vertex. So that's our vertex of our parabola. And with that said, we know the value of p. Let's go ahead and talk about the value of p. And remember, that'll lead us to our focus and our directrix. So our focus and our directrix is based off the value of p. All right, what does p equal? So we know in this example that 4p is equal to negative 12. So that implies p equal negative 3. So if negative 3, of course, that means our parabola opens down, right? We had a negative x squared term, so we knew at the beginning it's open down. But let's go ahead and draw in a sketch of what we found so we can get a picture of what we see here together. So our vertex here at 0, 0, this will be the max point of my parabola. It opens down, and I can draw a quick sketch of my graph here, opening down. So here's my upside down U-shaped graph. All right, let's go ahead and talk about these new pieces of information. So P was negative 3. So let's go ahead and plot in the focal point. So if I go down 3 units, I'm going to plot the ordered pair 0, negative 3. Right, there's that distance of P. P equal negative 3. So there's my focus, right, in my problem. And now let's do the directrix. So we went down 3 units. All right, we're going to go up 3 units to get to the directrix, which, remember, is going to be perpendicular to the line of symmetry. So we'll draw in the directrix. It'll be this horizontal line here. We'll dash it in. It's not part of our graph, and then it just helps give our shape, right? It defines our graph. And again, this is at 3 on the y-axis. This is the line y equal 3. This is our directrix, our parabola. So again, it's a distance of, right, 3 units. Remember, our value of p was 3. So we went down 3 units to get to focus. We went up 3 units to get to the directrix. So we've got our directrix, we've got our focus. So I'll put it over here. So 0, negative 3 being the focal point, and the directrix is the horizontal line y equal 3. All right, so again, that's looking at a parabola, right, in that problem. Let's go to another example. So let's take the next example. All right, we'll look at our next example here, work through it. All right, find the focus and the directrix of the parabola, y equal to 2x squared, and then graph the parabola. So same thing, let's analyze this graph. So y equal 2x squared. Of course, first thing I'm going to do is go ahead and work on getting it in standard form. Let's go ahead and isolate the x squared term. So x squared equal 1/2 y, right? Y divided by 2. Let's multiply both sides by half. And now we've got we've got our standard form, right? So again, we're trying to get it in standard form. And again, this is a graph, right, that opens up, right? This is a positive x squared graph. But our goal was x minus h squared equal to 4p times y minus k. So as we're looking at it, so again, this is x minus h. So as we're looking at our characteristics, we'll put it in standard form here. X minus 0 squared equal 1/2 times y minus, again, what's subtracted from y? Nothing. So y minus 0 squared, or y minus 0. So there it is in standard form. So we've got our value of h, right? We've got our value of 4p. We've got our value of k. So as we're finding our information, we've got everything we need. So our vertex, right, which is the ordered pair h and k, is again at the origin on this example. And let's go ahead and talk about the focus and the directrix. And again, we want the value of p, right? What's the value of p? So in this example, what do we know about p? So 4p equals 1/2. So as we go ahead and solve for that, we got to divide both sides by 4. So p equal 1/2 times 1/4, or 1/8. So p is 1/8. So 0.125. So again, it's greater than 0. Right? We know our parabola opens up. Right? We're going to go up 1/8 unit from the vertex to plot our focus. So let's go ahead and sketch in this graph that we found here. So we'll put our graph here beside us. And as we plot in, again, the vertex is at the origin. And we can go ahead and get a quick sketch right of our parabola. We know it opens up. But our focal point, so as we're looking at our value of p, we'll go up 1/8 unit. So that's the point here of 0, 1/8. So let's go ahead and plot that point. All right, back to our graph here. So again, plotting that point, 0, 1/8. So up 1/8 unit. So 0, 1/8. Again, here's our focus. There's that fixed point. There that parabola focuses on inside the parabola. And then we'll go down 1/8 unit. So we'll go down to negative 1/8. We would draw in this horizontal line. This is the equation of the directrix. So y equal to negative 1/8 would be our directrix. Right? Equal distance. So we went up 1/8 unit, value of p. Right? And we went down 1/8 unit. Right? So our focus, 0, 1/8. And our directrix, y equal negative 1/8, right, in that quadratic function. So we've graphed it, again, using our vertex being a key piece of information, and of course finding the focus and directrix. If we were going to try to draw it exact scale, right, we'd make sure this parabola, as far as the bend in it, the curve, that it's equal distance throughout as it is from the focus to the directrix. So if you want to get more detail, right, that's where we use those two pieces of information. All right, let's take another example. As we move on here, it says find the equation of the parabola with the vertex at 0, 0 and the focus at the point 5, 0. All right, so we talk about our parabola. Now let's go ahead and graph this information. So let's get a picture of what they've given us. So we're going to look at this parabola. Let's go ahead and draw an XY axis. We're given the vertex here at 0, 0. There's the vertex. And then we're given the focus over here at 5, 0. So here's the focal point for this parabola. And as we graph the parabola, we know since the focus is 5 units to the right, this is a parabola that opens to the right, right? So we know the parabola, again, always focuses in on that focal point. All right, that's inside that parabola. So again, a distance of 5 units. Right, there's the value of p. Right, p is equal to 5. So we've got h, we've got k, we've got p. We've got a parabola that opens to the right. So it opens to the right. We know standard form. Right, any parabola that opens right or left right? That implies standard form is your y term is your squared term. So y minus k squared equal 4p times x minus h. So let's go ahead and write in the equation. So in this problem here, we're looking at y minus 0 equal to 4 times p, which is 5, times x minus h, which is 0. As we simplify that down, of course, y minus 0 is y. 4 times 5 is 20. So we get an equation of y squared equal to 20x. And if you wanted to, you could go ahead and draw in your directrix. You know, they didn't give us our directrix, but we know since the value of p is 5, we go 5 units to the left. Our directrix would be this vertical line, x equal -5. And we know it's vertical because, again, it's perpendicular line of symmetry, which is the horizontal line y equals 0, right? That passes through the vertex right down the middle. So again, there's that value of p, right? That's equal distance, right? We've got 5 units to right to focus, 5 units to the left to the directrix. So again, writing the equation, given some information about this graph. So again, using our standard form, right? Quadratic function. So the parabola that opens up and down. We got x minus h squared equal 4p times y minus k. Parabolas open to the right or left, like this one. We have our y term as a squared term, y minus k squared equal 4p times x minus h. All right. Let's go to one more. Let's take this equation here. We'll take a look at it graphically. Now I've got a vertex, again, at the origin. So far all our examples been here at the origin. 0, 0 is our vertex. And then our focus is over here at -4, 0. So go ahead and plot in the focus here. And with that, as we graph in this parabola, we know this one's going to open to the left, right? So our focus is to the left of the vertex. So again, our value of p, right? P in this problem is a -4. Right? We went left 4 units. And if you wanted to, you could go ahead and graph in your directrix. It'd be over here at +4, which would be the vertical line x equal 4. Even though they didn't give that to us, we know the directrix. We could go ahead and write that in. But we've got everything we need to write our equation. So again, our standard form. So we're looking at a parabola that opens to the left, right? And with that said, we have y minus k squared equal to 4p times x minus h, right? All parabolas open right or left. We're looking at y squared term. It's our squared term. So y minus 0, y according to the vertex, 4 times p, -4, times x minus h, which is x minus 0. So simplifying, we get y squared equal to -16x. So there's our standard form equation, right? And let's take a break. We'll come back to these and look at our next examples.